Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at EEG. We will continue our discussion of EEG. So, in this video, we will look at variables in classification of EEG activity, recording the EEG electrode and the international 1020 system or the electrode positioning of electrode positioning of electrode placement. What are the variables in classification of EEG activity? There are say rhythmic patterns that you observe. Rhythmic means cyclical, consistent wave patterns at a relatively non-changing frequency or near constant frequency, essentially reflects stable neural activity. Now, that can be compared to let us go back to the stadium example. In the stadium that is having 1 lakh people, 10,000 people are chanting something in sync. Sachin, Sachin, 10,000 people are only chanting. Let us say that group I can identify. I am sitting and let us say I am inside the stadium, I am sitting and I am able to identify roughly this region, the sound is coming from this region, yet I do not know where the boundary is or which people are shouting in that and which people are not shouting. That is rhythmic activity, consistent wave patterns. Arrhythmic activity means some noise is happening, everybody is speaking about different things, they are all in the stadium and match is not happening. Let us say break is about to appear or it is a boring phase of the match, people are just chit chatting something, their personal things. They are chatting about a movie, they are chatting about the next day plan, they are chatting different things, they are chatting about office, they are chatting about something. A whole stochastic or noisy, it says chaotic waveform, but there is a difference, technical difference between chaos and stochasticity, but anyway irregular, not consistent, non-consistent, inconsistent frequency pattern suggested relatively disrupted brain activity. Sometimes what will happen is the entire stadium will shout at the same volume and the same sound and the same frequency, because hyper rhythmic. One would think, oh, that is actually a great thing, but actually no, that also is a sign of disease. So, arrhythmic means suggested some form of disrupted activity. When you say voltage, you are essentially interested in either the peak amplitude or the average voltage of the EEG. It depends on where you place the electrode and which method you use to record. Critically, attenuation, suppression, depression happens due to external stimuli. Either actually if you see attenuation, a lot of attenuation, 40 to 100-fold attenuation is happening due to skull itself. The skull is a spatial low pass filter. It essentially reduces signal amplitude 40 to 100 times due to skull and increases the resolution, not improves, increases the resolution to 6 to 8 centimeter square. This is why you do not have a good spatial resolution in EEG. But that is not what we are talking about. Here we are talking about signal attenuation may happen due to external stimuli. Maybe there is less stimulus, maybe a stimulus that is causing an attenuation is happening. Okay. The other is a form of attenuation where rhythmic activity suddenly stops due to stimulation. I am stimulating and then rhythmic activity that was happening has suddenly stopped. This is called as blocking. And then hypersynchrony, I already mentioned this, when a large group of neurons and the entire stadium is shouting, a sudden increase in voltage and regularity in all frequencies, alpha, beta, theta waves. This indicates a large group of neurons firing simultaneously or synchronously. The other is the paroxysmal activity, in which there is a sudden onset of high voltage activity from the background that suddenly ends, ending abruptly. This is often associated with epilepsy or epileptic patterns, but it is not always abnormal. So, there are always challenges in this diagnosis. When you record EEG, what are the things that you need? You need the EEG electrodes, preferably the silver chloride electrode, with electrode gel, appropriate electrode gel. Impedance now minimum must be below 50 kilo ohms. You need to position the electrode appropriately using the international 1020 system and the appropriate electrode EEG montage, and in a way that it avoids the movement artifacts. Preferably if the electrode is having amplifier inbuilt, that is what is called as an active electrode. This will help us avoid external noise and movement artifact in a very big way. But it requires electronics, right? Right then and there on the electrode you have an amplifier chip that performs a small amount of amplification, so that the signal is amplified. The noise that is coming due to, say, due to the cable, capacitance effects and all those things, or due to the movement of the electrode, are all minimized. So, active electrodes are advantageous, but these are expensive. There are different types of EEG electrodes. Peel and stick. You stick one electrode at a time, you peel and stick. Each electrode has a adhesive. You peel that adhesive label and then you stick, or with those that come silver plated cup, or sometimes these are used, these needle type electrodes are used under the skin of the scalp, slightly painful then. Sometimes they use what are called as electrode caps, those that contain the electrode already and then the person wears them. Right. These are materials. What are the materials? Stainless steel, tin, gold, silver, often silver chloride coated. Most commonly used ones are the chlorinated silver disc electrodes of diameter 6 to 8 mm. This diameter is important because they also limit the spatial resolution. The contact happens with the scalp via electrolytic paste or gel that. So, comfort is ensured by soft material, soft felt washer, some material that probably made of some polymers that ensures contact is maintained and comfort is maintained. The standard method for positioning is the so called 1020 system. It ensures that across patients a consistent, repeatable and relatively comparable EEG signal is collected. From the Nashion, you give 10% and then place one electrode, and then you give 20% and then you place one electrode, and then another from the Inion you give 10% and you place one electrode, and so on and so forth. Electrodes are placed either at 10% or 20% intervals of the head. Note that depending on the head dimension, this 10 or 20% will change, of course. Based on anatomical landmarks, based on Nashion, Inion and pre-auricular points, some specific anatomical landmarks are used. What are the advantages? The advantage is that this is a standardized method and I could reproduce this on the same patient. Let us say I did that yesterday, same patient shows up again, I can do that again, the same patient. Of course, it is not like my head is going to become very big tomorrow. Yes. And comparability. I tell a clinician in another lab that this is the method that I use, they can immediately understand what it is that I have done. Inter-lab or between lab comparability, that, and can be used in both clinical use and in research use. There are other methods, the so called 10-10 method or 10-5 methods systems that are used frequently for improved resolution, high resolution mapping, but the 10-21 is the dominant method. So, these are some of the electrode naming conventions. FP essentially refers to frontal pole, the function, roughly the function, okay, do not take it to heart. So, roughly spatial resolution is not going to be so high. Roughly in the frontal lobe you are doing executive decision making, attention. This. In the frontal lobe or in just anterior to the central sulcus, if you keep in the frontal lobe, if F, that is motor control, because that is the motor cortex and thinking or voluntary movement, and the central or the motor strip motor strip is a voluntary movement and sensation. In the premotor cortex and the frontal lobe, there is the motor control, thinking or association, motor association area, supplementary motor area and premotor area, for example. In the central lobe, in the central prefix, that is the just anterior to the central sulcus is the motor area, that is a voluntary movement. Or then you have the parietal lobe, that is essentially responsible for sensory processing, spatial sense, and this. Then you have the occipital lobe, that is primarily responsible for vision. Then you have the temporal lobe, that is believed to be responsible for hearing, memory and language. And then you have the midline ones, CZ, PZ and FZ, those that are essentially acting as central vertical reference points. Right. So, with this we come to the end of this video. In this video, we looked at variables in the classification of EEG and how do you record EEG, what are the electrode configurations, what is the EEG electrode, and the positioning of the EEG electrode and the international 1020 system. And we also mentioned the other systems, the 1010 and the 105 EEG system. What are the current developments in this field? Current developments. Dry electrodes, I already asked you to check those that use PDOT PSS. What is this? Conductive polymer based electrodes. Dry electrodes is a current development, is a currently developing technology, and up to 512 channels for improved spatial resolution, but only so much improvement in spatial resolution. Then wireless systems using Bluetooth, low energy. It's a commonly now up and coming topic. Right. Common misconceptions, what do you think? In EEG, does it measure action potentials? No, EEG measures the ensemble activity of many thousands or tens of thousands of neurons, if not millions of neurons. I earlier said millions of neurons. Depending on the neuron size, it can be even 10,000 neurons, 10,000 to 50,000 to 100,000 neurons. So, the EEG measures ensemble activity. Something to keep in mind. Then another thing is 1020 electrode system specifies location. No, actually, you have a 6 to 8 centimeter squared rough region within which anywhere you can. So, your spatial resolution is not high, it is in the order of several centimeter square, several units of centimeter square. The other one is, if you have a higher impedance, that means that signal quality will be poor, but nowadays current systems can handle signals even above 50 kilo ohms. Current systems can handle these signals by improved signal processing algorithms. Okay. So, with this we come to the end of this video. Thank you very much for your attention.